So there was a question asking why, when I wrote out the equations that describe a continuum body, I did not include the balance of angular momentum or the balance of energy. Okay, so equations of continuum mechanics. Okay, so why are not angular momentum and energy balance? Okay, that's somewhat awkwardly put, but I think you understand what I'm saying. Okay, the reason is that actually angular momentum was indeed included. Okay, and it was included in the fact that we wrote that sigma equals sigma transpose, or alternately that implies that and is implied by the fact that PF transpose is its own transpose. Okay, now you will recall that the condition under which the symmetry of the Cauchy stress holds immediately implies for us the balance of angular momentum, right? In fact, we demonstrated this when we derived the balance of angular momentum. Okay, so first of all, okay, so symmetry of the Cauchy stress implies and is implied by balance of angular momentum. Okay, and we proved this. So this part is done, right? So balance of angular momentum is included. As far as balance of energy is concerned, if we go back and look at our derivation of the balance of energy, what we will see is that it too follows, long as we are restricting ourselves to mechanical energy only, it too follows from the balance of linear momentum. Okay? So balance of linear momentum implies and is implied by balance of mechanical energy only. Okay, and long as we are restricting ourselves in our study of continuum physics to continuum mechanics only, right? This is assured. Okay, and essentially the relations that we get, if you recall, are that P external, right, equals P external, if you recall, is what it amounts to the power of the external forces, right, the body force and tractions, okay, and boundary traction. Okay, so P external we proved was equal to P internal, which is the stress power, right, something that we looked at again a couple of segments ago, plus the rate of change of kinetic energy. Sorry, I have a tendency to call everything a tensor or vector. It has to be curved. Okay, right? And the rate of change of kinetic energy comes from the fact that, yes, we have this material time derivative of the linear momentum, right, in the balance of linear momentum. So this is the sort of correspondence, right? The terms that amount to balance of linear momentum. Here we have the external forces, right? Here we have the stress, and here we have the rate of change of linear momentum, right? The balance between those quantities immediately gives us balance of mechanical energy, right? Now, when we go to other phenomena, things get a little more complicated. Okay, there we would have to include a different, we would have to include the balance of energy. I should just mention that if we're studying heat conduction, right, the governing partial differential equation there is itself the balance of energy, right? If we are studying transport, there is a different balance equation, right?